Hello, everyone. I appreciate you joining me today for this webinar. I promise you, those that were with us last week at Reliable Plant, we had a lot of discussions around defining terms, and it just so happens we pre-plan these webinars about 6 months to a year in advance, and coincidentally, um, it was my week to do a webinar, and just so happened I get to discuss this topic again, so which is awesome to me. But again, thank you for joining. We're going to be talking about maintenance terminology and defining terms, and this seems to be gaining some traction in the industry. And I'll explain some things and as to why and stuff here in a bit. But again, I appreciate you joining me. My name is Joe Anderson. I'm the co-founder, COO, Reliability X. I was a practitioner for about 26 years before we started the business. George Williams, Ramesh Galati, and myself are the owners of the business. So I've lived this life, been in this world, started as a maintenance mechanic, worked my way up into corporate management before leaving to start this company. And so I appreciate you joining us. Who is Reliability X? Well, we're an empowerment company. And the way we see ourselves is our job is to make your job easy and try to keep things simple and to empower you to be able to do your own plant turnarounds and make your life easy, the quality of life for your folks easy. I take pride in this business, and we're the only business in the world that have 2 CMRP of the Year award winners, 2 CRL Black Belts, 2 Uptime award winners. We received the Solutions Award last year, and we also own the Maintenance and Reliability Best Practice book, which is the best-selling book in our industry for the past 15 years. And so take a lot of pride in that. I'm proud of this company and what we do. And I appreciate you guys again for joining us. So let's jump right into it. When it comes to defining terms, now, we're not going to solve the world's problems today. Really, you probably might have more questions than answers. Am I right? I don't know. I'm not claiming to be right. I'm just trying to spark a conversation. But I think if we use tools that we have at our disposal and years of experience, we can start to see some of the things that we define and the way we define them don't quite add up to the words that we use. And so that's where I kind of want to get. I don't think we'll definitely solve it. And I don't know who's right and who's wrong. Just wanting to have the conversation. But we got to understand that in the maintenance and reliability space, we've kind of dug ourselves into a hole with the way that we define things and kind of created our own language and only included ourselves within that language, and that put us in a box. And now anytime we talk about maintenance, everybody only thinks about the maintenance department. And the same thing we did with reliability, the term reliability, now most people think reliability is a maintenance thing. And that couldn't be further from the truth. But I think that's because of the way that we've gone about defining terms and things. It's created a problem for us. And we continue to make it more and more complex. We take things like preventive maintenance or predictive maintenance or reliability-centered maintenance, and we define it however we see fit instead of trying to come up with the universally accepted terminology. And so, again, that puts us in situations. For example, reliability-centered maintenance is a methodology that helps us develop a maintenance strategy. But some people will call this their maintenance initiative. They'll say, oh, we do reliability-centered maintenance, and you go and you have conversations and you go tour their facilities, and all they're doing is PDM routes on bearings, and they're calling their program Reliability-Centered Maintenance. And so, it creates a lot of issues. I get it. Reliability-centered maintenance is an attractive term, but it is not a culture. It is a tool or a methodology. And so examples like that we see are prevalent within the industry. It also leads to a lot of miscommunication, varied strategies. Like I said, if you tell me you're doing RCM and I have one definition in my head and you have your own definition, we're speaking a different language. So I make assumptions that you're doing certain things, and I ask for your RCM analyses, and you say, "What are you talking about?" Um, you and I are on a different page. And so having a consistent vocabulary helps us all in the industry. And then you couple that with now all the AI and IIoT folks jumping into this field and creating their own terms and defining things their own way that most of them have never worked a day in maintenance in their life. And now they're defining maintenance terms and coming up with their own terms. It just further muddies the water. And, I think a part of it is intentional. And I am a consultant, but I think part of it is intentional so that the more confusion we create, the more you need me. I think part of it is just a lack of understanding. People don't quite understand what it is they're talking about. And so that's a thing. But I also think ego plays a part in it. I think we've done very poorly as a society elevating certain things within experience. Well, we've definitely elevated education over experience, and that's created a lot of issues. So people coming out of school with a degree think they're smarter than people with 20 years of experience that have actually lived that life. And we also set requirements around hiring people based on that standard. And I've experienced that myself. I got my college degree late in life, but I was told I wasn't qualified to run maintenance departments when I had 15 or 20 years experience, and a kid straight out of college with a degree was qualified. And so we've done a very, very poor job as a society elevating. We call it higher education. And I call that kind of the managerial class, or, it's developed there's a stigma that these people are smart and everybody else is kind of dumb. And, that's created issues. So you've got a piece of that as well. And I think we're paying the price for that now, because now the market is saturated with these smart people and they provide minimal value. And so not all, I don't want to use it as a blanket term, but most, for sure. And so, and here we are, further complicates things. So again, my theory is, the way that I teach it is, these smart people, they take simple things and make it very complex. And by doing so, that creates bureaucracy, and it stifles an organization's ability to be flexible and move. And I've seen this now, being on the consulting side, time and time and time again. Where value-added people, we take the complex and we make it simple. The goal, the reason why KISS, keep it simple, stupid, is a thing is because of common sense. The simpler it is, the easier it is to get results, and the better results you get. And for whatever reason, we're enamored with complexity, which I don't understand. But the goal is keep things as simple as possible, define things in simple terms. Doesn't need to be complex. Go out and execute and get results. And then I yesterday, 2 days ago, was watching a video by Eli Goldratt. Goldratt wrote The Goal. He wrote Critical Chain, The Haystack Syndrome, some of these books. He taught Theory of Constraints. Phenomenal guy. But he had this quote in this video I was watching, and it kind of made me laugh. But he said, somehow we have this admiration of sophistication. And the more sophisticated it is, the more respectable it is. And if it is sophisticated to the point we don't understand it, then it's gorgeous. And where the hell is that coming from? He's talking about implementing theory of constraints and how it's common sense and it's simple. And yet, for whatever reason, we have an admiration for complexity. And you see this with automation, you see this with IoT. It's not that those things don't have benefits. They do. In the right application. The problem is people think that's the solution to their problem. And it is not a solution to your problem. It helps give you data. You still got to go solve problems. And so we've created a society of problem tellers and not many problem solvers. So if you go out to the floor and be a problem solver, you'll get results fairly easy. So let's get into some terms. First, I'm going to start with a few acronyms. We will define these acronyms. But total productive maintenance, TPM, that is a thing. PDM, predictive maintenance. PCM, precision maintenance. PM, preventive maintenance. Preventative wasn't a word until about 5 years ago. They added it to the dictionary because we couldn't say preventive correctly. Corrective maintenance, CM. Time-based maintenance, TBM. Condition-based maintenance, CBM. RCM, Reliability-Centered Maintenance. FMEA, Failure Modes and Effects Analysis. OEE, Overall Equipment Effectiveness. And TEEP, Total Effective Equipment Performance. So some of the basic acronyms, we're going to get into defining these, and I'll try to put a method to my madness, hopefully put it in a structure in which it can make sense. And then we'll define terms. Effectiveness versus efficiency. What is an organization, a plant, a system, a process? There's a lot of confusion around them. What is maintenance? There's a lot of confusion around that. Prescriptive maintenance, that's a new term coming up for an old thing. Then we have condition monitoring. Some people say condition-based monitoring. Emergency maintenance and reactive maintenance. Those I'll get to, but are technically self-contradictory. Proactive maintenance, and these new ones, criteria-based and rules-based maintenance, we'll get into. All right, so let's begin defining terms. Let's start with effectiveness. Now, again, there's a method to my madness. Hopefully it kind of starts to make sense as we walk through this, but a lot of these things are related. Effectiveness, by definition, is doing the right things or the right work. It has the term right in it. Therefore, if you're not doing the right thing, it is ineffective. Okay. And so, for example, in maintenance, do you have all your equipment documented in the system? Have you done a criticality analysis? Do you understand how it fails? You know, how do you mitigate the failures? And what about potential failures? Those are some of the basic right things to do in maintenance. The goal is to have a strategy that's based on failure modes, and we'll get into that in just a second. So effectiveness means the right work or the right thing. Efficiency is the ability to accomplish something with the least waste of time or effort. The word right is not in the definition. And we use these terms interchangeably. We say, is it effective? Is it efficient? Efficient, effective? And we don't understand what we're really saying when we say that. Effective means, are we doing the right work? Efficiency means, is it streamlined? It doesn't mean, are we doing the right work? I can be doing all the wrong work, and I can make that process of doing wrong work more efficient and get results. They're smaller results, but you can get results. For example, I use this example a lot. A lot of you have probably heard me talk about it, but it's simple. It's a lot easier to understand. If I have a 55-gallon drum of used oil, and my current practice is to dump it down the drain, and I just kick over the 55-gallon drum, spill oil all over the floor, and most of it, let's say 70% of it, gets down the drain. And I want to make that process more efficient. I could get a barrel tipper, a really big funnel, and a forklift, and I could slowly dump the oil into the funnel down the drain, getting about 99% of the oil down the drain. Now I streamlined it, little time or effort, and I got a almost 30% improvement of how much oil I got down the drain. But the question is dumping 55 gallons of used oil down the drain the right thing to do? And no, it is not. The EPA would disagree with you. Your state compliance would disagree with you if you say it's the right thing to do. Therefore, it is ineffective. So I can make that process more efficient. I can be doing all the wrong things and make it more efficient, but the wrong thing means it's ineffective. The question that we never ask is what we're doing the right work? And this is why the Lean Six Sigma people catch so much flack, because they'll take a current process and they'll make it more efficient. The question is it the right process? I'll give you an example. To get rid of defects, I had a client that created a lot of defective packages. Their CI group, their Lean Six Sigma practitioners, or whatever you want to call them, their focus was, how can we make opening defective packages more efficient, instead of how do we get rid of defective packages? And so the question is the work the right work or not? Is it effective? Okay. Now, with that, let's break down a few things. So an organization, again, simple terms, I'm a simpleton. We can debate these if you want, I don't mind. But an organization, the way I define it, is a collection of plants. And a plant is a collection of systems. And those collection of systems, those systems we call departments within our plant. We have a quality department, a safety department, a maintenance department, an operations department, a logistics department, whatever, HR. Every one of those departments are a single system. And those systems must work together to create a well-oiled machine called a plant. Okay. So a system is a set of interconnected or interdependent processes that work together to achieve a common purpose or goal. That's called completing work. Okay. That is a system. It's a bunch of processes that work together to complete work. A process, a department, is made up of a bunch of processes, or your system. So maintenance as a department is a system. The maintenance system is made up of a series of processes. I typically say there's 15 foundational processes at a minimum that make up the maintenance department. Some will have more than others depending on regulatory requirements and things like that. But there's 15 processes. So if we think about one of those processes, planning and scheduling, does the planning and scheduling process complete work? No, it doesn't. But it helps work along in the process. So these processes work together to create the system, to complete work. They, in and of themselves, do not complete work. That is a process. So we have an organization, a plant, a department, or a system, and then process. Okay. Now, I say all that to say this. Total productive maintenance, TPM. A lot of experts in this field, and I've seen books written by them, they call TPM, they think it is autonomous maintenance, which is a part of TPM, yes. Okay. But that's the operational side, or operator driven reliability is what some people call it, piece. But they'll say that TPM is AM, autonomous maintenance, and that is not true. Total productive maintenance is a system. It touches every department. And it's a comprehensive system of equipment maintenance that aims to achieve perfect production by preventing breakdowns, process failures, speed losses, minor stops, and other defects. The goal of TPM is to integrate maintenance into everyday operation of every single department, from top down, from the CEO to the janitor. And it does it in small group activities, and there's a pillar function. The goal of TPM is to improve equipment effectiveness. Now, we defined effectiveness, the right work. Okay. The goal of TPM is equipment effectiveness. The main objective is to increase the overall equipment effectiveness of the plant. That is measured by what we call OEE, overall equipment effectiveness. Okay. And then to improve asset utilization, which is measured by what's called TEEP, or total equipment effective performance. These are measures on how effective you are at operating your equipment. This has nothing to do with efficiency. When we do the right work, downtime is minimized. It's about effectiveness, not about efficiencies. When we do the right work, defects aren't allowed in the system, which we'll get to. Okay. But these two measurements, OEE, TEEP, these are the main objectives of TPM. TPM has 9 pillars. Everybody takes a piece, 1 or 2 pieces out of it and says, oh, I'm doing TPM. It's like, no, TPM affects the entire organization. It's not an operations and a maintenance thing, although those are the main 2 drivers behind the whole thing. Everybody has a piece. This is where we've put ourselves in a corner, because anytime we mention the word maintenance, everybody associates maintenance with the maintenance department. But if I say, whose responsibility is safety? Everybody. Well, how is that? It's not the safety department? What about quality? Everybody. How is it everybody? It's not the quality department? But you're telling me maintenance, and more specifically reliability, is just maintenance's responsibility? And this is how we've ended up in the situation where, okay, it is everyone's responsibility. Everybody has a piece in maintenance, everybody has a piece in reliability. But we have to define what the term maintenance means. And we'll get to that. With OEE, overall equipment effectiveness, It is a measure of equipment effectiveness against the scheduled time to run the asset or assets. That means if the line is planned to be down, it does not affect OEE. I get so many people that try to tell me things like changeovers and all this stuff is included in OEE, and it is not. OEE is a measure of how effective you are when you're supposed to be running, not when you're supposed to be down. A changeover is planned downtime. You plan in the schedule to take the line down for, say, 30 minutes to do a changeover. That's planned downtime. That does not go against your OEE. And OEE is calculated by multiplying what we call availability, performance, and quality. Availability is all your breakdowns, process failures, setup and adjustment downtime taken out of your scheduled time to run. And that gives you a percentage. And then whatever time is left moves down to performance, and then you pull out minor stops and speed losses, and that gives you a percentage. Then whatever's time is left from that moves down to quality. And once you remove your quality defects, because you can convert it to time based on the design rate of the line, it gives you a percentage, and you multiply the three together, and that gives you what's called OEE. That's how effective you are at running your equipment. Then you have what's called TEEP. A lot of people will tell you OEE is asset utilization, and that is not true. The problem is we've lied to the government reporting it for so long that if we reported the truth, it would crash the economy. But that's a whole nother conversation. So TEEP, it takes your scheduled time to run and divides it by the calendar time of that same period. For example, if you're scheduled to run the line 120 hours a week and there's 168 hours in the week, you take 120 divided by 168 and it gives you what's called the loading percentage. And you take that loading and you multiply it by your OEE, and that gives you TEEP. That is your asset utilization. It's how often what percentage of the time based on that calendar time that you're measuring against that you're utilizing your asset. That means that includes all planned and all unplanned downtime. So when you see you have 20% asset utilization, don't be shocked. It's very common. 60% is world class, TEEP. 85% OEE typically. Mhm. Again, how effective are we at running our equipment? If we have a lot of downtime, we're ineffective. Okay. With that, let's move on to defining maintenance. What is maintenance? Well, simply put, it's the act of maintaining. Well, what does maintain mean then? If you look up the root word maintain, it means to keep in an existing state, also called base condition, which means it's basically defect free. That's base condition. It also means to preserve from failure or decline, to guard or protect. So picture a knight in shining armor standing in front of the asset, not allowing any defects into the system. That is maintaining. Not allowing defects in. That is maintenance. The act of keeping it at base condition. Keeping it defect free. The problem is we have all these terms now where we throw the word maintenance behind it. But if we understand that proactivity and maintenance are synonyms, for example, reactive maintenance isn't actually a thing. It's self-contradictory. We have a term for that. It's called repairing. But we just lump everything together and call it maintenance. But it's actually not maintenance, it's repairing. Once a defect initiates, we now have to react. That reaction is a repair. Now, depending on where we repair it at, that's the question. Okay. So what maintenance is not is it's not firefighting, it's not turning wrenches. Just to turn wrenches. Now, there's a level of it when it comes to what we call precision maintenance, but that's doing the maintenance things that are keeping defects out of the system in the first place, like using our torque wrenches, doing laser alignment, double checking our work. But all this reactive stuff that we talk about is basically repairing. But I digress. So, other terms, a failure mode. A failure mode is a deviation of function or behavior. It's the effect of the failure mechanism. A failure mechanism is a deviation of condition or cause of the failure mode. Okay, so every asset or component has functions. And the way in which it can functionally fail, the cause behind that is a failure mode. The cause behind the failure mode is the mechanism. Then you have what's called a failure code. That's an identifier in a CMMS system. A failure code. When we go to close out a work order, we typically want codes in there so we know what type of failure it was. Proactive maintenance. Here's one where we throw the word maintenance behind it. But proactivity is the set of actions or the mindset of doing things or mitigating defects and not allowing them to happen in the first place. Are things going to wear? Yes. Yes. So there's always going to be a level of reactivity. It's not a positive or negative thing. It depends on what the percentages are. My thing is, in simple terms, proactive means you control the assets, which means you have the information necessary to understand the asset's health. This is why we set up PDM routes. This is why we do precision maintenance. We manage our lubrication practices to give ourselves the information we need to know what oncoming failure is headed our way. So we can continue to monitor to such time we take the line down and replace the component in a planned downtime situation, never leading to unplanned downtime, which is not unplanned downtime, but a breakdown. I haven't defined loss buckets. That's for another session, but a breakdown is the loss bucket that maintenance is responsible for, or accountable for, I should say. And a breakdown, by definition, is any unplanned stop 10 minutes or more and requires a part to be replaced. We find 70 to 80% of a maintenance guy's time is spent on what's called a process failure. It's any unplanned stop 10 minutes or more and does not require a part to be replaced. What that means is we're typically out adjusting machines because we haven't done a great job training operators. But a breakdown we can prevent because we can find it soon enough to replace it in a planned downtime scenario, so we're never taking unplanned downtime. That is called a zero defect strategy or zero breakdown strategy, and it is attainable. Then we have reactive maintenance, which is self-contradictory. If maintenance in and of itself is proactive, how can it be reactively proactive? It's like saying a square triangle. It's a self-contradictory term. This is called repair. It's either planned repair or it's unplanned repair. Typically, when we say reactive, we mean unplanned repair. But reactive is a cultural mindset that focuses on restoring equipment to normal operation after a breakdown. This means the asset controls you. So, proactivity, you control the asset because you've given yourself information to be able to make decisions and know where your defects are. Reactivity, asset breaks. You're going to work on asset whether you like it or not. That means the asset controls you. And I don't know about you, but being in maintenance, I never like to be controlled by my assets. I like to have control over my assets. Then you have run to failure, and there's two different ways to look at run to failure. The proactive way is that we made a decision as a business based on criticality and risk to say we're not going to do any maintenance to this asset because there's no risk to the business. So when it fails, we'll just order parts and replace it as necessary. And that's okay if your strategy assessed risk and you found there's no risk to the business. The reactive run to failure that we like to talk about a lot is because we have a lack of a strategy that will prevent equipment failure. So we just wait for it to break and we respond. That's typically what we mean when we say run to failure when we're talking amongst ourselves. But that is not good. One is good, there's no risk to the business. The other one is not good. Run to failure. Then you have preventive maintenance. Preventive maintenance is a program, and that involves all sorts of preventive maintenance activities. And I'll share a graphic, kind of how I see it. But what we typically do in maintenance, those that are reactive in nature, we do these things on the weekends. We call them PMs. It's a piece of paper that prints out that we take out to the line and we do a PM. But typically in that PM, it's not detailed enough for us to actually make an informed decision. It's more an opinion. And we'll get halfway through a PM and we'll find something bad and we'll take the time to replace it, leaving the realm of PM and now entering what's called corrective repair. Because our inspections, it says check the chain, and we check it. I think the chain's bad, so I'm going to replace the chain. Okay, but how do you know the chain is bad? Are you using a chain wear gauge? Is it 2 to 3% stretch, so it needs to be replaced, or are you just guessing? And we spend this time and we do this over and over again. We'll get about halfway through a PM, our day's up because we replaced a bad bearing, we replaced a chain or something. Never finishing the PM, but we'll sign off that we finished it. Then Monday morning, we don't start up. We'll run again. Next weekend, we're doing these things we call PMs again. Never truly getting any of the defects out of our system, hardly any. Because during the week, we should be doing a majority of our inspection and our defect identification tasks. So that on the weekend, when we are planned to be down, we're working on restoring equipment back to base condition, which is maintenance. And we want to know why we're in this vicious cycle. It's because we continue to do PMs all weekend, never doing the corrective work to get the defects out. We'll get 1 or 2. But if I find 100,000, how many am I going to get out on the weekend? Instead, we'll do PM, right? So there's 9 types of PMs, which I'll kind of go through their PM types, right? And you should be separated into PM types. If you're not, you need to do an optimization. But I'll show you the graphic and the way I deem things. Then you have predictive maintenance. Typically, when we talk about predictive maintenance, we're traditionally talking about 5 technologies. That's infrared, ultrasound, vibration analysis, oil analysis, and motor circuit analysis or electrical signature analysis. There's a 6th one with motion amplification. Haven't quite figured out where to put that one yet. It's kind of it's a PDM tool, yes, but it's other things as well. But typically when we say PDM, that's what we're talking about. And then there are some forms of non-destructive testing. A lot of people lump that in there as well. But the most common typically are these 5 technologies. Precision maintenance technically really is just maintenance by definition. But it has now become a thing, which I get. But it's typically things like proper bearing installation, using torque wrenches, doing laser alignment, doing balancing, any of those types of things. All those things that we do typically when the machine is down to ensure that we haven't put defects back into the system. PDM, on the other hand, typically has to be done when the equipment is running or is energized. Like, you can throw a disconnect and then come back and shoot the bucket, but with IR, right? But you're not really going to get a proper reading, right? So the disconnect has to be energized, right? With precision maintenance, typically you're de-energized, okay? Then we have this term corrective maintenance. This is just repair. But now that we've thrown the term maintenance behind everything, we call it corrective maintenance, but maintenance by definition is not repair. Repair is repair. Maintenance is to keep at base condition. So I would say this is corrective repair, and that's to perform activities that correct defects. Okay, now there's 2 types. There's planned and there's unplanned. Okay, so unplanned means we're doing it in a downtime situation. Planned means we identified a problem or a defect and we're going to correct it with the line down, so we're not taking unplanned downtime. Okay. Then we have reliability-centered maintenance, RCM, which is a systematic approach to identify the most effective maintenance strategies to ensure reliability and safety of assets. Okay, so again, it's not your maintenance program. It's a methodology or a set of tools that help you develop your maintenance strategy. FMEA, so RCM uses FMEA. They kind of call it an FMEA on steroids. But FMEA is a structured tool to help you identify potential failure modes and rank them based on severity, occurrence, and detectability, which gives you a risk priority number. So you can rank your failure modes, and your higher rank failure modes, you're going to try to address those with certain strategies. Now, these 2 terms here, even amongst experts, is a lot of debate. And there's kind of 2 fields of thought. Okay, but I'm going to share with you mine. Maybe I'm wrong. Like I said, I'm not here to say I'm right or wrong. I'm just telling you things how I see it. I could be completely wrong on all of this stuff. Okay. But this is why we need universally accepted terminology. But condition-based maintenance, I would say, are condition-based inspections. That's where the goal is to assess the condition of an asset, a part, a component. Where time-based maintenance is a time-based replacement regardless of condition. So it has nothing to do with calendar time or cycles or stuff like that a lot of times. Like even your condition-based stuff is done on calendar base. Like every month I'm going to go out and pull my oil samples. Every month I'm going out and doing my PDM routes. All of that would be considered condition-based maintenance. So a lot of the confusion comes around when we define time-based maintenance as doing maintenance at some interval. That would lump everything pretty much under that umbrella. And so that's where the confusion comes in. And so this is how I define it. Again, up for debate. Even within our organization, we can't agree on this. So that just kind of shows where we're at, okay, when it comes to terminology. Because some people have there's an RCM kind of approach to this, and then there's a, I don't know what you would call it, just digging yourself out of a reactive hole approach to this. I don't know. But, there's a couple different approaches. And so again, it's not that anybody's right or wrong. The question though is how do we define it? And this is why the discussion needs to be had. Condition monitoring, that is where tools or technologies are used to monitor condition of an asset, part, or component. Condition-based monitoring is just another way to create confusion. It's condition monitoring. We just call it condition-based monitoring, but we already have an acronym for CBM. We can have like 58 CBMs and no one would know what you're saying if you say CBM. I think we just create too much confusion. Again, smart people like to make things complex, and they think they're just the coolest people that come up with these terms, and half the time don't even know what they're saying. So, we've got to be the most cool and innovative and show how smart we are. Okay, well, so be it. But I don't really see it as a thing. It's condition monitoring. These two terms I've been hearing a lot recently, criteria-based and rules-based maintenance. This isn't actually maintenance activities, but a way that you would set up your CMMS system to make it more user-friendly so that you can start having your system work for you. Okay, but we throw this word maintenance behind it. Again, I think we throw the word maintenance behind everything to market to the maintenance world. And again, maintenance is everybody's responsibility. Everybody. But here we go, putting ourselves in the corner again. Emergency maintenance. I hear this a lot. That isn't even a thing. It's self-contradictory. If maintenance is proactive, you can't have emergency proactivity. Like it's self-contradictory. That's like saying reactive maintenance. Okay, you can have an emergency repair for sure, or unplanned repair. Emergency is a priority, which is different, but whatever. Another one, prescriptive maintenance. Prescriptive maintenance is just PDM or condition monitoring with a recommendation on how to correct the issue. So it's a fancy term for people who want to kind of feel good about themselves, but it's an oil analysis report. You pull a sample, the report tells you recommendations to correct something if they see an anomaly. That would be prescriptive maintenance. But again, fancy schmancy terms, making things complex for no reason. And so but this is my opinion again, so it is what it is. So kind of the way I see things, put in these buckets. So you have preventive maintenance. This is your program, all the different types of PMs. And then you have corrective repair. You have planned and unplanned corrective repair. So you have these 9 types. You have calibrations, testing. So testing like safeties. You go around, test your safeties, right? Adjustments. This isn't really changeovers and getting call out to machines. It's more seasonal stuff or major engineering, resizes because are completely switching to a different product. Not like a changeover, but getting rid of one size product and going to another size product permanently. Lubrication should be lubrication management should be its own thing. Rebuilds and overhauls should be their own thing if they're major things, not replacing certain components on a given time. That's not a rebuild or overhaul, but that'd be a time-based replacement. Recommissioning is one. So, if we go replace a pump, recommissioning, there's a precision maintenance piece that has to take place. In some industries, revalidation. Then you have condition-based inspection, and under that sits PDM, your IoT, condition monitoring, any performance testing, or defined measurements. So using a chain wear gauge, for example, to inspect for elongation, that would be a condition-based inspection. There has to be a defined measurement. That means we're specific behind things. What we find with PMs is it'll say, check the chain, calibrate the scale, test the safety, lube the bearing. All on one PM every week. Well, do you need to lube every week? Do you need to test the safeties every week? Do you need to calibrate every week? Right? Like, this is why things need to be split into PM types. So you have PM types, and then you have corrective types, corrective repair. Okay, and then there's a new term I learned last week called reability. This is the ability to gain again, or maybe they've just taken the lie out of reliability. If you know, you know. I'll leave that one there. So, in closing, am I right? I don't know. It's been easier for me to explain and teach others this way. Maybe it's completely wrong and I'm off base 100%. Maybe I am. So it is what it is. But will we be able to fix this issue? Probably not. If anything, it's going to get more complex because now we have other people coming into the industry that know nothing about maintenance and are creating new creative terms, and everybody tries to be innovative. We can't even fix a sandwich, and we're in here trying to define terms. So what I say is keep things simple. Let everybody else be smart. Let everybody else sit in a room and talk about what the terms are and all that stuff. Just go out and do. Go out and do. Go eliminate losses and defects and go get results while everybody else sits in a conference room and talks about it, and it'll change your life. Honestly, it's that simple. Go out and solve problems. I'm sure can agree with me that you've sat in meetings and everyone can tell you what all the problems are, but no one does anything about them. Be the one that does things about them. Life gets good. Results are awesome. It's a good life. If you disagree with anything I said, if I'm off base, send me an email. Let's talk about it. I don't mind talking about it. I'll have this discussion all day. I'll tell you you're right, I'm wrong. Maybe change my stance. I don't know. The whole reason for this is to have more discussion around it. And I think we definitely need a universally accepted terminology. Scope creep is going to get huge. And especially with AI and IoT becoming the next shiny thing, all these words with the term maintenance behind it are going to start popping up more and more, which we haven't even defined maintenance properly yet. So to throw that word behind things makes it, again, self-contradictory a lot of times. So, but with that, I appreciate you being here. If you have any questions, anything you want to discuss, send me an email, joseph.anderson@ReliabilityX. Visit our website at reliabilityx.com. Got a lot of resources out there, blogs, things like that, that we share quite often. And do me a favor, scan this QR code, evaluate this webinar. Tell me how much I suck at defining terms, whatever it is. Give me some feedback. Let me know what you think. If there's any topics that you can think of that you would like us to talk about, let us know in that evaluation when you scan that QR code. Also, check out our column in Plant Services, Captain Reliability column. It's a satire column where we get to poke a little fun at the industry. It's good times. Plant Services, great magazine. Recommend it. If you're not subscribed, check it out. And with that, I'll be gone for the day. Again, thank you all for joining me. I appreciate your time. Again, send me an email. Let's have a conversation. Let's talk. And thanks for joining me. You guys have a great day.